continue the chapter 3 for the data pre-processing. Actually, the data pre-processing data is kind of the data mining technique. It's not just the pre-processing, it's kind of the pre-processing. Sometimes if you can complete the data pre-processing part, the 90% job is already done. The others are just the practical implementation. So the pre-processing nowadays is very important. Also, because nowadays we have a very huge amount of data. Sometimes, most of the time, the data are not very clean. Clean means it's formatted and no garbage data, and semantically it's also corrected. However, if you take a look at the data itself is not doesn't make sense. So sometimes of the data. So today we are going to see what is the data pre-processing, how much is important, and some of the techniques. We will take a look at the data pre-processing technique, including data cleaning and the integration and reduction. Also, the data reduction is not only just to reduce the number of data, but also the reduce the number of attributes. Because nowadays most of the data is high-dimensional data. Sometimes it has 1,000, 10,000 of the attribute, so which reduce the performance as well as the accuracy. So we will see such a data reduction technique, and then we will talk about a little bit about the frequent data mining, which is the first part of the data mining technique. Okay. So what is anyway, before we start, what is the data quality? How we can measure whether data is cleaned or not? How can we judge whether this data is clean? This one time when I joined I think it's 2012, it's 2.5 years ago, almost 3 years ago. I worked for during the summer, I worked for one of the bank. So to analyze their customer data set, they provide the customer databases. So in terms of size, it's only part of that is just the prototype system. So I used around several gigabytes, and they provide me something customer data. The goal, I will show you later the final code of that. The final code is very high level. They provide the account information. Both, so actually that bank works for the student, the account, the student ID card. So sometimes I'm not sure whether UB ID card is also working for the debit card. Is there any functionality for debit? No. So some of the student ID card works with the debit card, which means if you deposit some of the money, you can use that deposit money for the store or the restaurant. At that time, some of the state waive the state tax or sales tax, so you can get the benefit, like the point at UB. So if you buy the point, the UB card, actually you don't have to pay the tax when you purchase the coffee or some snack in the UB cafeteria. So that is the account information that they provide. Also they provide, in addition to that, they provide, that is the 10 years ago student information. It's a student information. After that, some of the students actually continue the account for the salary account, which is actually very important for the bank, because every month, every 2 or 3 times a month, there are incoming the cash. So 10 years later, whether this account still exists, and plus the information. So they try to see what is the pattern. Oh, okay. Actually, the percent in terms of percentage is less than the 2% or 3%. Only the 2% of the student continue after graduate as a salary account. It's a kind of the checking account for the deposit of their salary. So we'd like to see what is the characteristic of that 2% and what is the characteristic. Yeah, the 28%. Also, whether we can credit this 2% and whether we can increase by the 1%, 2%. That will be the huge benefit for the bank. At that time, when I received the data, it looks like just a number. So, like for example, the customer level is like 1, 1, 2, 1, 2, 1, 2, and something the income is something 0, 1, 2, only number. So I need to implement something program that can, because these data are from the relational database. So their customer level information or income level information or other information are in other table. And so, but they do not provide such an information because of the other security issue. So I need to ask the data architect and any the paper information, so the hard copy information, then implement something program to replace meaning of them. Sometimes they are ordinal data, sometimes nominal data, so and sometimes scale the 0 to the forever, and sometimes weird data, income is minus or something, and which is not loan. So to actually clean up such all the data, I spend most of time. Then actually after I clean the data, applying the data mining technique, it's just a couple of days to find the rule or the something pattern of that. So just like that, data preprocessing are very, very important. Sometimes it's a very, very tedious job. Okay, in terms of the data analytics, data mining technique itself is already implemented everywhere. So unless you are focusing on the new or enhanced data mining technique, so as long as you can use the existing data mining technique, the main problem is how to pre-process such a data. Also how to understand whether this should be nominal data, this should be ordinal data, this should be category in terms of whether I need to normalize data. Or sometimes many of the data are null also. Whether I need to keep null data as it is, or whether I need to replace such a null data. Whether how we can handle such a missing data. So to do that, you need to be expertise on this data set, the domain expertise. So to judge it, whether the data set are the clean, so to measure such a quality, we can consider the accuracy of the data, whether it's completed, okay? And the consistency is also important. Some of the data are not consistent, okay? So, for example, here, so level is 1 through 10, the other is 1 through 5, whether we need to adjust, so normalize, it's the same scale or not, okay? And also timing, in terms of time, whether that makes sense or not. If out of date, sometimes we don't have to, we cannot use such a data, okay? So, in terms of that, so we will process such a data before we apply the data mining algorithm. It can be classified into several categories. First one is the data cleaning. So data cleaning part, we can fill up some missing data, okay? And also sometimes, because of the error, it has the, for example, income level is mostly the less than 10,000. Then 9,000 or 8,000, but sometimes it has millions. Okay. Obviously, this is a mistake. Okay, something error. So how can we handle such an extreme case? They may affect. Okay, if in error, if there is a data like the 10 million, the 1,000 million, they may affect the result of the data mining technique. So we need to smooth such a noise data. Okay. And also integration, because sometimes the data are coming from many different sources. And the combine into one, just like the data warehousing. Data warehousing is a collection of the multiple sources data. The one is from the online transaction, another one is from the system log, then the third one is from the sensor data. So we need to combine all different data sources. So at that time we need to, because nowadays data integration is also one of the hot issues when we deal with the heterogeneous data, okay? And how to combine. Data reduction, this is very important. Probably some of the students who are doing the research already encounter such a problem. When we have that, there is a saying like the curse of the dimensionality. Curse of dimensionality means, so when you have the more than 15 degree of dimensionality, you may lose accuracy. That means, for example, I'd like to compare, I'd like to classify the type of person or the human being. So I can consider gender or something, the personality, and something, the language, mother tongue language, and just like that. I can classify easily. However, think about I'm going to, so the more dimensionality maybe the better, so I pick up the number of hairs and all details of human being. So I have the 10,000 information. Okay? So which one will be better, do you think? Sometimes the less important attribute, even though I have 2 or 3, that will be better, easy to classify, easy to mine. So even though you have the 10,000 different characteristics, many of them are common, okay? Even they may lose the accuracy. So for example, the example of such a curse of dimensionality, x1, x2. We have 2 points. First is a 2-dimensional data. So we have a 0, 0, and 1, 1. x3 is 10, 10. So we can easily recognize that these two are close and this one is kind of an outlier. Or we can make the 2 groups. What if we have the 10-dimensional data? One, two, three, four, 5, 6, 7, 8, 9, 10. And this one. It is hard to say which one is close, which is not. Okay? Even though, in addition, if we have the very extreme data, okay, so we can use the Euclidean distance. So we can compare each component, then square root, either square, then root, then we can get the data. The more dimension we have, such a difference, a small difference, may be reduce the importance of this factor will be reduced when you have the high dimensional data. So that is called curse of dimensionality. So curse of dimensionality, it happens most of the data set. So solution, we can reduce the dimension. Okay? There are different ways of the dimensional reduction. So for example, if we leave this one and this attribute, so working together, which means it's related, then we can pick up one of them. How can you find whether data are related or not? That time we can consider covariance or the variance of the attribute. We will see details about that in this chapter. Okay, that is the dimensional reduction. Also, sometimes we can reduce the data itself. If many of the data are duplicated, redundant, we don't have to process all of them. But should be careful sometimes. Such a number of the duplicate data have the meaning. with something importance. So frequently happen. Okay. And also, we can transfer. To simplify the problem, we can transfer such a data like the instead of the bunch of number, can we find the kind of the equation to represent such a high dimensional data? Then it will be simple problem. That is the idea of the regression, statistical approach of the regression technique. Okay, instead of the bunch of the data, we can find some optimal linear equation. Okay. So we will see this slide shows the overview of the data preprocessing. So I think that's the same idea. We can clean, so shiny. Clean means shiny, and from the different data sources, we can make the one clean data source. Also, we can transform the data instead of the different scale. We can make the same scale. So it's for example, -1 to 1, something like that. And also, the data reduction can reduce the number of the data and the number of the dimension also for better processing. So, data cleaning. How to clean the data? In case of the incomplete, we can make the fill of the missing data. Yes?
Excuse me, data cleaning.
Yes.
Say that it's data tuning and the
Data
analysis.
tuning?
Yeah.
Tuning.
What does that mean, tuning?
Tuning, we can fix any error or like the messed up data.
If that is the
So
definition of the tuning, I think that is the same thing.
Yeah.
Okay?
Okay, so all these kind of categories in that
Mhm.
meaning.
Yes.
Part of that.
Yes.
Yes.
So for example, if you have the missing data, but if you can find the missing information from other data source, so you can like from relational database that I introduced, that I gave you as an example. So you can, by accessing the existing database source, you can find some of the, for example, the occupation of the customer 111. You can find the occupation from other data sources if you can do that. But not always it is possible. Okay. Also, sometimes the missing data can be derived from the existing data, such as GPA. Okay. If GPA is not calculated using your grade, student grade, we can calculate such a missing data. Okay. Not always possible. Okay. And also, noise data means it has the data, but doesn't make sense. Like, for example, salary is -10. What does that mean, -10? If there exists any meaning of minus in the salary, yes, we can consider, but mostly it's not. At the time, it can be some of the database use minus as a kind of error or something unusual case. Otherwise, it will be error, so you need to take care of such a data. And also inconsistency, obviously that doesn't make sense. So 42 years old, so 2010, right? 2010 maybe less than 10 years old. So it doesn't make sense. You need to consider either of them or just one of them. Okay. Also, for when you see the financial data, you will see a lot of the level or the grade of the customer, grading level or credit level, something like that. Sometimes it use the 1 to 3, or sometimes ABC. Both of them are it's a category, right? So there is no specific meaning of 1, 2. It is not the number. So, but just the level. At that time, you can make the consistency by changing one of them to the other. Okay. Also, if you do not know, or if your customer does not provide the correct data, so intentionally you put the default data, like the January 1st for the birthday, okay, the date of birth, or some salary in terms of salary 0. Okay, 0 does not mean actually no salary, so they don't wanna release the salary information, something like that. Okay, how can we handle? It is depending on your data set itself, it can be changed. But that is the data cleaning. Okay, So I think I already implement such a detailed case. Also, one of the things you need to be careful is, so, for example, unknown. Unknown can be considered as the one of the class. Class means you will hear a lot such a class or level. Okay, for example, we have 6 number, so I classify this number into these are odd number, this is an even number. We can say this is an odd class and this is an even class. Or we can label as odd, even, odd, even, odd, even. Okay? So it can be considered as a class, can be considered as the group or the kind of classification, or sometimes a class or group. Cluster, it's the same meaning. So which means we can consider unknown data, unknown level as the one of class, one of the group, meaningful group. In that case, we can keep such an unknown data. Otherwise, if you believe that is just error, then we need to find the way to replace it. Sometimes we can consider the mean value of the data as a default, the missing data. Okay, so mean value. Also, it's a mean value of the specific class. If you can narrow down the data, like for example, if we miss the one of the data, but this is the group of the female. Female usually we can find in that group we can find the mean value. So something like that, but not always the mean makes sense. So we need to, at the time, depending on the case, we need to infer the missing data. Okay? That's very, very hard. It's kind of the problem actually nowadays. For example, one of my students or couple, they are doing the user profile. User profiling in the social media data. So, for example, Facebook, because of due to the security reason, they do not release all personal information unless a user agrees. So unless the user open that personal information is hidden. Okay, but the Facebook no. So what if we can guess? Okay, what if we can find such a user specific information like the gender or location or occupation, age group. Think about the real cases. So if you see the Facebook information, Facebook message, sometimes you can easily guess whether the Facebook user is a man or a woman, even from the profile image, right? And also whether where the user is living right now, right? From the message, if the user mentioned about a lot of Times Square or the New York Manhattan, probably at least the user is visiting certain place, Manhattan, New York, right? And occupation, probably the student mentioned about a lot of midterm, final exam, and the class, the professor. So we can easily guess. It's the same idea. Using such information, can you guess, predict such a missing information? It's the same thing nowadays. We can infer such a missing data that are valuable for marketing or the other applications. So that is a user profiling. It's not just the data preprocessing is one of the main tasks in social media data. Okay, at that time, Bayesian approach, Bayesian formula is mostly used technique. Bayesian technique, as I introduced the last time, Bayesian technique using the other information we can actually guess. So we will see detail later. So we will, for example, the probability probability of the A based on B can be inferred using A based on B. Okay, that is a base. And probability of A, probability of B. Using this information, we can get such a conditional probability. So that is a Bayesian approach. Using Bayesian approach, we can actually infer many of the information. That is a part of the preprocessing. And in terms of noise data, we can reduce some of the noise data, duplicate data, incomplete data, inconsistent data. Okay, but how to handle the noise data? So you can actually use several techniques. So binning means bin is kind of bucket. Okay, so we can make the partition bucket and then assign the sort to such a data. So if we, in case we have the outlier extreme data, so we can actually make some average by the bucket, by the bin. We may not lose the overall characteristic of the data. For example, if we put this data into such a bucket, so they are 0 to 10, and some of the rule using the bin. So this data has the similar one of this. Then the even extreme case, the noise data will be one of this. Then we can make the kind of the same value, or we can apply some mean value, or so we can apply the median value to smooth it by B. Okay? And revelation is the revelation, and we have the data like x and we have two random variables, x and y. So we can get, for example, y equal x. It's not exactly, but we can optimize this value into this y equal x. This is a revelation technique. So if we have something noise data, this data doesn't follow this, then we can ignore, or we can adjust to that y equal x. Also clustering, we will see the details of the clustering later. Okay, the clustering means, for example, in this example, so we can actually make the two groups from this data, because they are close and they are close to each other. Okay, this is called clustering. In other words, grouping. Did I give you any information about the data? Without such information, everybody can expect there might be two groups in this example. That is called clustering. When at that time, if we have 1 million, so all of these are either lower or upper value, but this is an extreme case. So it cannot be one of these. Otherwise, we need to this. Okay, so at that time we can consider this one as the outlier, the extreme noise data. Then we can remove or discard or adjust to the closest one. Okay. And also, obviously, the human can involve, okay, to address such a problem. Not always easy. Manually, once you have a huge amount of data, it's not easy to address such a problem. Okay? We can use the commercial tool sometimes, but not always. That is also most of the cases where the domain knowledge should be involved to clean up such a data. Okay? And also, for the migrating or the integration, so in the data warehousing system that we are not going to cover in this class, so I'm going to jump chapter 4 and 5. Then we will discuss about the chapter 6 after this. 4, 5 years. So that deal with the data warehousing or the OLAP, the tool. That's more like the application part. But if we will discuss about it, there's the ETL, a lot of ETL tool. So extraction, transfer, the load the data, which means when we get the data from other data sources, like we have the relational database and something the log data, system log. This can be stored at our data warehousing system. So extraction, not all the data will be transferred. Some of the data will be selected or the pre-processed, then transfer and load into the data warehousing system. So this is a commercial tool. There it is a commercial tool we can use such a ETL rule. At that time, we can actually clean up such a data. Data integration nowadays is very important to think about. We'd like to merge the two banks. Okay, the one bank, Bank A, used customer information as the NM instead of name. So for example, customer name and employee name or something name, the salesman name. And another bank, they use the name for the NAM, customer name, employee name. But when they merge it into one system, you can do manually. What if we have the 10,000, 100,000 different cases? It's not easy for manually to converge these in same meaning but different, the name. Okay, so that is the problem of the data integration. Even that is worse for the attribute level. In the attribute, sometimes the employee, EMP, EP, the EP name, bunch of different ways of for naming for the same data. So how can we match such a thing? So at the time we can, easiest way, naive way is manual work. But as you can guess, the manual work does not always provide the good solution. Because don't believe the manual work. Manual work is not always the best solution in terms of accuracy. It's a very, very subjective. So somebody decide the employee name is the same as customer name, it will be merged. So to address that one, there are several research, not several, many researches to find the meaning of, for example, customer NM and customer name. How can you find? So using the attribute of this data, whether attributes are similar, whether it has the name, address, and so on. So then finally, they can provide the percentage probability of the matching. This one and this one is a 70%. This one and this one is a 10%. Okay, so they provide the possibility or chance of the matching. Then finally they can decide. Even it's worse if we consider data level. Like actually Bill Clinton, his name, full name of the Bill Clinton is William Bill Clinton. Anyone who knows before? But it's the same name. William Clinton is the same name as the Bill Clinton. So the full name is William Bill Clinton. I think that there's one more at the middle name. I forgot. So actually the Bill Clinton is the same as the William Clinton. How can we decide? You can see some of the examples of the entity identification matching in the Google Scholar. So if you go to mine, the Google Scholar, you can see a lot of paper which I didn't publish. Why? Because that system matches the similar name. Okay? If their system is correct, actually it shows only the paper that I published. But so probably in your country, in your hometown, you have a lot of people who share the same name, right? So their paper is linked. They are linked to my name. So we can see a lot of the paper which is not related to mine. So that is a problem of the entity identification problem. So how can we address? So we can do the definitely manual, but it doesn't work for the large database. The time we can consider the attribute, or sometimes, for example, in terms of the publication paper, you can see co-author information also, whether co-authors are common, and also area, research area, how much common word, frequent word in the two papers, something like that. Okay. But anyway, this is one of the hard topics, data integration part, in terms of entity level, entity type level, table level, and in terms of attribute level. Nowadays is data level, entity level, the integration. So, how can we find such the correlated data to reduce the dimensionality? At that time, we can use the chi-square test. Chi-square test provide is formed as a sum of the expected the observed value minus the expected value square divided by expected. Okay, that is actually ideal case. So ideal case means if two attributes are independent. So observed means is simulated or tested or the collected real information. And expected means so ideally we can get percentile. Okay, we will see the example. You may not get the idea of expected. Expected means is in ideal case I expect, for example, I have 10 students. How many the female student? How many male student? Okay, observed I don't know until I count. But expected is 5 and 5. Okay, so that is the expected. So if the data are independent, not related, this might be the same. Observed and the expected is the same, so it's a 0. So in using the chi-square test, so if data are independent, it will be 0. Otherwise, the data, this value will be increased. The observed and the expected value will be larger. Okay, so then we can decide the two attributes are the related or not. So let's take a look at the example of the real case. We have two attributes. One is the gender, okay, male, female, and we have the another attribute that is the preference of reading. One is the fiction, another one is the non-fiction. So we have the 300 male and 12,000 female students. Okay, not half and half. At this time, this one is given 300, 1,200, 1,200, and also the fiction we have the 450, and we have non-fiction 1,050. So we try to find whether gender is related to the reading preference using chi-square. In ideal case, in other words, independent, if they are not related, the fiction, because the distribution of the male and female is 1 to 4, and also the fiction and non-fiction is 45 to 105. So anyway, this 4 divided by 9, 2, 21, 3 to 7. Okay? It should be, this one should be 3 to 7. And this one should be 1 to 4. That is 90 expected value. 90 and 360. You can see it's a 1 to 4. And this one 210 and 840 is 1 to 4. And also this one is 90 to 210. That is the 3 to 7. And 360 and 840 is a 3:7 ratio. So value inside the parenthesis is an ideal case, which means independent. We can guess, okay, if they are not related, male, the gender, and the reading preference. So, but when I ask the 1,500 students, 250 male likes the fiction, and 200 the female likes the fiction. We expect this amount of student, okay, but less female and more male in fiction. Also, non-fiction is much less the non-fiction for male and much larger than expect for female, which means something weird decision, which means relative. Okay, how can we calculate such the correlation using this equation? So observed minus expected. Observed for each cell. Observed 250 minus expected. So that is the 60 square divided by is expected. Okay, denominator is the 90, and for each cell, then it's a 507.93. Okay. However, this is not scaled, so we cannot say whether this is a very strong or very weak correlation. But anyway, it's true. So it is relative. Okay. How much we need to decide the guideline. Okay, based on experimental result. Okay, that is the chi-square calculation to decide whether two attributes are related or not. Yes? No? Okay, the next one is the other way to decide whether the two attributes are related or not. That is correlation, the numerical data. You can see, I think that you may see this kind of equation in the statistics. Okay, at this time, the A bar and B bar means is a respective mean of A and B data. Like this, not observed, not tested, is the ideal case. Okay, based on the data set. So that is the, where is it? The A bar and B bar. Okay, and the sigma A and sigma B is the standard deviation of A and B data. Okay? Then this will be the actually simplified as the A times B and minus n times of the A bar and B bar in statistics. So using this one, this output of this is called correlation coefficient for A and B attribute, two attributes. So to do that, we can, from the data set, we can, without testing, we can have this value and this value, and for each we can actually the times cross product for all 1 to n. Okay, then we have the standard deviation. So in case this one is the positive value, they are correlated, otherwise it's independent. Okay, so that is the, in case of minus, it's a negative correlated. So this one is a positive relative, and this one is negative relative. Okay, so that is the another correlation in analytics. So this is a visual result. So this is the negative, and this is the positive, and this is this one not related. Okay. You can see the correlation as the linear relationship, like this one. From the, if they are related, it will be linear. It can be represented as the linear equation, or the negative, the relation that is mentioned here. Okay. Also, covariance is used a lot. Covariance is similar as the correlation. Okay. The difference is covariance is derived from the correlation and the standard deviation of the data. Okay. So to find the covariance of the A attribute and B attribute, we need to find the correlation data from here. We can find the correlation data, then times the covariance at the standard deviation of A and standard deviation of B. That is the same of the A minus A bar. A bar is the what? Expected that is the same as this one. The mean value of A and B. So expected mean value of A and B. Okay. Then minus from the data. Okay. So then expectation. So that means if data are not much related, so this value will be the zero, right? Covariance is the zero. Otherwise, the value will be increased. That can be derived from the correlation. Okay. And positive correlation is if A is larger, then B is larger too, like this way. And otherwise, the negative independence, it will be zero. So in case we have the high dimensional attribute, the data, we can find covariance metric. So attribute A1, A2, AN, A1, A2, AN. This one is definitely zero, right? Because it's the same thing. It's a zero, right? Case A1 and A1 is the same thing. Then covariance, you can find A1, A2. Covariance A2, A1, A3, A1. Like that. So you can find the covariance. Then using covariance, you can actually reduce. You can find any subset. You can apply the linear algebra to simplify such a problem. Okay, let's see the example for the covariance. So we have the two attribute data, so 2 and 5, that is one data item. Another one is 3 and 8, 5, 10, 4, 11, 6, 14. This is the stock market price, okay, for a week. And this one is the price of A, 2, 3, 5, 4, 6, and 5, 8, 10, 11, and 14 is for the price for B. So we try to find whether the A and B are related. For the expected the mean value is the sum of sum of them divided by 5 is that's 4, and this one is divided by then 9.6. Okay, then we can subtract each data, okay, and multiply. So 2 minus 4, right? Or we can apply the covariance is we can simplify the covariance EAB minus AB. So we can use this equation. Okay, so 2 times 5 plus 3 times 8 plus the 5 times 10 and so on, and divided by 5, that is the expectation value A product B. Okay, minus 4 times 9.6 is 4 is a positive value. But you should be careful whether 4 is huge or the weak covariance. We don't know yet. Okay, at that time we should know the overall, the characteristic of the data. In this case, 4, as you can see, 2, 3, 5, 4, 6, 5, 8, 10, 11, 14. Not very strongly related, but anyway, we can see the evidence they are related. Okay, but we should be careful. That is the reason there is no judge how much they are correlated. So we need to evaluate the other data set, whether it's based on the empirical result. The next topic is the data reduction. Okay, so there are different types of data reduction, but mostly dimensionality reduction. We have the data itself, so we can reduce, for example, the redundant information. But mostly nowadays, when we are saying the dimensional reduction, that is a dimensional reduction. We have the data compression.